So last time I mentioned that magnetic fields are created by moving electric charges. So if we have a charged particle, and well, of course, it will have an electric field. But if this charged particle is also moving, then it will also create a magnetic field. And this magnetic field will interact with external fields. So suppose we have a uniform magnetic field, maybe between the poles of strong magnets. So let us say we have a magnetic field in this direction. Okay? So magnetic field, the symbol for magnetic field is the capital letter B, and it's a vector field, so it has a direction. Now let us say, for example, that we have a positively charged particle, let us say positive Q, and it travels in the magnetic field with a velocity that is directed that way. Now, there are experimental observations on the magnetic force exerted by the magnetic field B on this charged Q, okay? And the factors that determine the magnetic force exerted by the external field on the charged Q are the charge, the magnitude of the charge, the magnitude of the velocity, well actually the magnitude of the velocity component perpendicular to the magnetic field, and the magnetic field strength. Okay, so experimental observations revealed that the magnetic force exerted by this field on this charge is directly proportional to the magnitude of the charge. So the larger the charge, the larger the magnetic force. Also, the magnetic force is proportional to the component of the velocity perpendicular to the magnetic field. So there must be, like for example, if the charge is moving parallel to the field, then the magnetic field B will not exert a magnetic force on the charge. So if, let us say, the angle between the magnetic field and the velocity of the charge, this angle here, let this angle be phi, okay? Then the component of the velocity perpendicular to the magnetic field will be this. So it's directed this way, and this is V sine phi. So we could say that the magnetic force is directly proportional to V sine phi. Also, the magnetic force is directly proportional to the magnitude of the magnetic field. So, the magnitude of the magnetic force exerted by the magnetic field B on this charge Q is given by these relationships. So, we can summarize them into an equation. So, this will be our first equation for magnetism. Magnetic force on a moving charge. So the magnetic force on the moving charge is equal to the magnitude of the charge times V sine phi times, or we could write this as F is equal to Q, magnitude of Q, VB sine phi. So this gives us the magnitude of the magnetic force on a moving charge. Well, magnetic force exerted by this external field B. Now, this only gives the magnitude. Now, for the direction, we could use the vector form. Recall that the cross product of vectors A and B is equal to the magnitude of A times the magnitude of B times the sine of the angle between A and B. So if we consider the vector V, velocity vector and get the cross product of it with the magnetic field vector, then we have the magnitude of V times V times sine phi. So therefore, this part here of our equation is actually V cross B. Okay? So this is actually V cross B. So therefore, we can write the vector form of the magnetic force exerted by a field on a moving charge as F. So that's a vector. So therefore, it has a direction. It's equal to the magnitude of Q, okay, times V cross B. Okay? So this is the magnetic force on a moving charge.